Alright, in light of a recent conversation that I've had with a certain colleague of mine, I decided I'd do some research on concept. Uh, and granted, this is not really the concept that we were talking about. The specific concept we're talking about was concept within the explicit directive instruction model for teaching, and I'll call that EDI from now on. So, in light of my arguments on concept, I use the EBSCO host to search for one key term. You got it, just concept. And this educational search, I checked all of the boxes. I wanted anything it had on this. So here's the debate. Before I get into my research, the argument was about solving two-step equations, such as 3x plus 6 equals 21. And my opposer states the concept is that of equality, that you need to keep the balance. If you do something to one side, you must do it to the other. And this person always will put their hands out to their side and do this little dance. But the thing about this, the reason why I have issue with this is because, okay, if I do one thing to this side, I have to do it to that side. So what if I want to add 4 to both sides? Would that keep the balance? Why, yes, it would. But would that give me the correct answer? No. What if I want to add a star to this side and a star to that side? Sorry, I don't have my slate with me, so my stars came out weird. But what if I wanted to do that? I did it to one side and the other. What if I wanted to, I don't know, what if I wanted to draw on crayon on this side and draw on crayon on that side? Would that not be keeping balance if I kept it equal? The problem with this idea is that it only tells me one part of a pretty hefty concept. So what I believe is that the concept for equations is a three-part thing. And the idea is that you need to, let me get my magic pen here again. The idea is 4 parts. So I think you need to get the variable alone. And let's me not use that one because that's zooming out of my screencast area. I wanted to use my spotlight tool. There we go. So the idea is to get the variable alone. This would maintain a balanced equation. Now this is just a visual. And I believe the concept in math especially has to be more than just a visual. Now, it doesn't matter what it is, but you always need to make a 1 or a 0. That's how you do it. If you want to get x alone, if you want to isolate the variable, you're going to do this by making 1s and 0s. And then that's the how we're going to do it. And why? Why? Because we're going to use the identity property to get the variable alone. Now, if people understand, which you should be teaching these things, that the inverse operation is doing the opposite to make a 0 or 1, and with addition, the identity property is plus 0, and with multiplication, the identity property is times 1, it'd be very easy to see that you simply subtract 6 from both sides, because that would make your 0. That'd be a 15. And then with your 3, you'd simply divide both sides by 3, because that would make a 1. And 1 times x is x, and it's fading away, but so that would have been x equals 5. So that's a clear concept that lets us know exactly how to solve the equation. So I had a C with my teacher if I'm right here. Now, so here you go. This is one way I teach the concept of inverse operation and identity property. So this is what I call the card trick, and let me just go ahead and set something up that will be easy for me to demonstrate this. This would always work. It doesn't matter what the cards are, but and the way this works is all the numbers are their face value. Jacks are 11s, queens are 12s, and kings are 13s. So if this was my second set of cards, I have to use all 5 cards to get this bottom card as an answer. And the idea behind it is if you see this right here, this 10, you automatically should notice that 10 is what you are looking for. And so now, and it doesn't always work this way, but you could always get a solution. And so it's kind of a number play idea. But now I notice that, hey, with these two cards, I can make a 0 or a 1 because 12 divided by 12 is 1. Now, is that going to help me? Not really. But 12 minus 12 is 0. Then I could use it, so I could cross that off and cross that off as a 0. 0 times 7 is still 0. 0 times 4 is still 0, I'm sorry. And then 0 plus 10 equals 10. So that gets people used to the inverse property. Now, you subtract 12 minus 12, so a positive 12 minus 12 equals 0. That's inverse. At the end, 0 plus 10 equals identity property. And then we'll play that game for several weeks before equations, and I'll start introducing that those are the very same properties we use for equations. Now, so I found this concept of concepts, concept terms, knowledge organization, by this Marathi A person. So let's see what they say. It says, does a concept, and that's not the button I wanted to use, let me use this one. The concept represent its reference, or is it a creation of the mind? Can a concept be analyzed in parts or elements? Must the concept be general? And I do apologize, I don't have my slate with me, otherwise I'd underline that perfectly. Refer to a category or a type, or can it refer to a single object, physical or mental? Are concepts as clearly delimited as terms are concepts voiceless terms? And what do terms contribute to an individual's and community's conceptual richness? I'm not sure about you. When I read those lists, I had a kind of a brain meltdown for a minute. So I had to think about this and create it in my own words. So is it a representation of patterns, or is it a mental creation to remember? So are we looking at reality and finding patterns, or are we creating an image like a balance? Okay, second, can we break concepts into parts? My colleague said no, we can't. It's got to be one idea. It can't be broken up into parts. Can it be an overgeneralization, such as a scale balance? Are they merely picture representations in our minds, or they're actually something with the words, or something with the mental processes? And then also, how does a concept aid to education? How do we limit concepts by the definition of its terms? So I kind of, with that last point, made it more pointed towards what I was looking for, but I thought that is a pretty good representation. And this paper was much more on philosophy of concepts, kind of more on a religious and philosophical, seeking truth type of thing, but I thought it was pretty cool. So the first question, is it a representation of patterns, or is it a mental creation to help us remember? So this is what I found. The concept is not built from the mind. So it's not a mental trick out of its own materials, but rather it's obtained by abstraction from facts. So this statement is saying that we come up with a concept. It's not supplied by the mind if it has not been supplied to the mind. So we're actually taking these thoughts and synthesizing a general idea from them. Okay, but many authors underline that men's minds, and I think this men's is men and women, I think. I don't think it is actually specifically talking about males, are not passive receptors. They collect and group into categories what otherwise would be lost in the chaotic multiplicity of experience. In doing so, the mind selects some elements from a flow of experiences of fathomless depth and extension. So, in other words, we find patterns to make things easier from the facts. We have all these things, and that this concept idea is something that we can find the patterns and create a more easy to understand grouping. It's kind of like chunking your phone number up. Try to remember 10 digits, it's very hard to do, but if you remember 334, that's not too bad. And then we have this doozy right here. So not only do we symbol specific facts, we add elements previously in existence in any of the facts observed. So the creation of the mind aimed at introducing in order that the apparent chaos of facts. So this element right here was a different philosopher kind of got a different opinion on it. in that same section. So there is a little bit of ambiguity, a little bit of disagreement here, and I thought that was interesting. But let's go ahead and move on. So can we break concepts into parts? And I was very happy that there was no ambiguity here. They said, and this was quoting from the reading, on this point, authors are in agreement. Concepts are units of thought, but such units, not unlike atoms, are by no means indivisible. So with my thought with the equations, yes, the big overarching theme is you're getting the variable alone, but there are parts to that. It's not just keeping a balanced equation. You could keep a balanced equation forever and never get the correct answer, correct solution. It's about using the inverse property, create a 0 or a 1 to empower you to use the identity property to get the variable alone while keeping the equation in balance. Okay, so must concepts be an over-generation, such as the scale balance? With universal ideas, it is so important to distinguish between the comprehension and extension. We call comprehension the attributes that an idea includes and that cannot be removed without destroying it. So I can say the problem with the scale is that we can destroy the idea with the scale. I can say, well, I'll just add a star to both sides. That's maintaining balance. But that's a destroyed already. With the idea I present, if you take out any one of those elements, it would not work anymore. The three leading figures of modern British empiricism uniformly maintain that the supposedly general concepts are but concepts with particular reference, so references to specific ideas, assumed as symbols of other similar specific reference. On the contrary, Kant states that concepts by their very form are universal. So this just shows that this argument between me and my colleague has been going on for ages. That's basically what I got there. So it's the whole idea of hold apart. This is much more my thought process with a teacher, that I want to give you the whole idea and then build the parts in between. And even though you might have these gaps, you kind of understand the overall picture, like looking at a puzzle. Whereas this, there's an overall idea, but the student doesn't know what exists out here because you haven't shown it to them. You're just building it part by part by part. And then hopefully over time, you'll have the entire idea there. Okay, so are they merely picture representations in our mind? The relationship between object and concepts is natural, while that between concept and term is conventional. Yet the apophonic language describes the essence of reality, hence it cannot be conventional that it is used to decide truth. Okay, so in other words, the words are what we get the truth from. That's kind of what I got from there, and that it's the words are the way we express that picture in our mind. So I'm realizing this is getting long, so I'm just breezing by quickly now. How does the concept aid in education? How do we limit concepts by the definition of a term? So my findings. Whenever we limit ourselves by saying it's always this way, we close the door to a potential need. Concepts are not cookie cutter shaped. Sometimes they are more abstract. Sometimes they're more picturesque. Even the philosophers argued on either side of whether concept was generalized pictures or evidence of specific observations. An interesting side note, Pythagoras, great math man, was convinced there were only whole numbers and math could only be expressed through proportions. There's a legend that has it that he was killed because he wouldn't succumb to a proof that the square root of 2 could not be a whole number. Somebody needed to teach him the concept of rational numbers, and that's actually from a video I saw from viheart.com recently about Pythagoras, which was really kind of funny. All right, that's 14 minutes long. That's enough of your time, so I hope you enjoyed it. All right, bye.